at 11. Yeah. Let's start until we have 1 minute left. So what we will do is we will go through the practice assignment once. Okay. After that, we will see the solve with us questions. Let's start while others join. So we have practice questions. I think the first question is that we have to download the data set from the following. We have this is the link of the data set which is given to you. Okay. So if you go to the link, it will show something like this, a great data set which is there. And if you open it in Google Colab, it will look like this. Okay. So we have different columns, V1, V2, V3, V4, V5, and target. Okay. So if you see the column details are given here. So this is a blood donation data set. So V1 is the recency, that is the number of months since the last donation. V2 is the frequency, which is the total number of the donations. V3 is monetary, so the total blood donated in CC. V4 is the time, time remains, defines the months, defined by the months since the first donation. And V5 is whether the donor had any fever or anything in the last month. The target variable, which is the last column, this column, okay, the target variable is a binary variable representing whether the person donated any blood in the March. So as we can see, there are yes and no, these two values in the target column. So what does that mean to us? That means yes stands for donating blood and no stands for not donating blood, right? So obviously, first thing we should do is we should download the dataset from the given link and upload it to our runtime, which we have done here. Okay, so we have uploaded the file, the CSV file, and then what we do is we start importing the library. So we start importing libraries and modules, whatever we need. We start to import. Okay, so obviously we go with NumPy, we go with pandas and seaborn. Okay, also we have to plot different data sets. Okay, we may have to plot, so therefore we go with pyplot. So from matplotlib we import pyplot as plt. Then we import some other things, import OS, import requests. We have to see what are these things doing here. Okay, and then we import our required functionalities. So from scalar.preprocessing, we import standard scalar, one hot encoder. And so you can see, as we have discussed yesterday, previous class also. So one hot encoder imports the categorical features in a numeric array. The standard scalar, what does standard scalar do? Standard scalar also standardizes the features by removing the mean and scaling to unit variance. So if you have x minus mu by s, where mu is the mean of the training samples and s is the standard deviation. Okay. So so all of this we are importing from scalar.preprocessing. So other things also like ordinal encoder, which again encodes the categorical features as an integer array. Okay, and we have the other thing called min max scalar. So we have standard scalar, min max scalar, one hot encoder, ordinal encoder. All of these are from scalar.preprocessing. Okay, so min max scalar, what does it do? Min max scalar transform the features by scaling a feature to a given range. And so corresponding formula is given. And obviously we need other details like column transformer is there from scalar.compose, and we have scalar.pipeline. Okay, so pipeline from scalar.pipeline, and to connect to add to combine two pipelines we need feature union. Hence we have feature union. So feature union concatenates results of, as you can see, it concatenates the results of multiple transformer objects. So feature union concatenates multiple pipelines, multiple transformer objects. This estimator applies a list of, 1 minute, there's someone in the chat window. Yes, import OS and import request I also have to see. Let me see what is this. Let me see. Okay, 1 minute. So as you can see, request is an HTTP library. So okay. So think it's some library to for connecting with python.org. Okay, I am actually not sure what purpose they are serving here. I'll just check. Okay, this is requests, and for import OS, let me see what is import OS. Into your POSIX depending on, I don't think okay, let's do one thing. I think they may not be required. Okay, let's comment them. If we face any issue, we can come back to them. Okay. If you, I am not sure. Does anyone else have any thought on this, where the import OS and import requests are used? Let us see how it goes. So we import pipeline, we import feature union as we are discussing. Again, we have imputers. So two types of imputers we have, simple imputer and KNN imputer. Both come from, again, sklearn.impute. So whenever you are imputing something, just remember that it comes from sklearn.impute mostly. Similarly, we have logistic regression. Logistic regression comes from linear model. RFE comes from, again, as it is feature elimination, recursive feature elimination. Therefore, it comes from where? Sklearn.feature selection. We are selecting by eliminating, right? So from sklearn.feature selection, we import the recursive feature elimination, and from the same module only, we will import sequential feature selector. So you can actually write from sklearn.feature selection, import RFE, comma, sequential feature selector. I think who was asking, 1 minute, who was asking in the chat, Sunita. So it may be the import OS and import requests may be required for showing the structure of the pipeline in the HTML form. Okay, I will just check. This is just my guess, but I think they may be useful for showing the HTML structure of the pipeline which we see. Okay, and same goes for set config. Let me see. Yeah, thank you. So fastly, what we do? Okay, let's run. Okay. So download the data file in CSV format, then upload it to runtime, which we have already done here, and then read it from the virtual disk. Let us read CSV, as we all know, and then we divide it into the X and Y. Okay, so up to 5th column is X, and remaining the target column is Y. So first question is, how many samples are there in the data set? So obviously we can so how many samples are there? So what we do is we just calculate the shape of the first column, and so if you see, this is X dot shape will be 748. Then how many features are there? So if you see for 1, it will be X dot shape 1. So that is 5. What type of problem is this? Is it a regression problem? It's a classification problem, clustering, or association rule finding. So if you hint is look at the target variable. So if you see the target variable, it is basically classified into yes and no, right? So therefore, it's obviously a classification problem. So it's a answer is classification. Since the target variable is binary, it is a classification problem. And so how can we know that what are the target variable values? So we just put y dot unique. So y dot unique actually returns the unique values of the series object. Okay. So what are the unique values that are present? So what are the unique values in this column, the target column? Okay, that is our yes and no, right? So therefore it returns the unique values of the series object as they are appeared. So unique values are returned in order of appearance. Okay, and it does not sort. So if you put y dot unique, then it will give yes comma no. No sorting and anything is involved here. Then the next question is, which of the features has least variance? Which of the features has least variance? So you ignore and remove the missing values, if any, and are there any categorical features? So let us see what we do here. Yes, I think someone was posting it in the discourse also, that how can we understand that which feature has least variance. So one good example here is to plot a box and whisker plot. Okay, and we all of us know how to plot a whisker and box and whisker plot. So we can check v1 equals to x dot v1 dot replace with 0, and sorry, not a box plot, we are doing a violin plot here. And if you see, for every case it is mostly the if you see the case, it is mostly the v5. Which one is v5? Okay, so we have v1 dot replace. So v1 is the first one. Then we have v2, sns dot violin plot data v2, v3, which is here. Okay, the left, below left column. And we have v4, which is the fourth column here below right. So v1 is if you follow my cursor, the top left is v1, top right is v2, top bottom left is v3, bottom right is v4. Okay, so therefore what we have here is so now the question is whether v1 has the maximum variance, or v5 has the maximum variance, and so on. So v1, v2, v3, v4, and v5. So why now from these box plots also we can't find it, right? We can't find, because none of them we have to check the v5 as well. So 1 minute. Yeah, sure. So what we do here is basically simple. So we have plot dot figure fixed size is the instruction in the question to remove missing values, not replace them. So it is actually removing, replacing with the it is actually replacing with 0. So we can say it is removing or ignoring the values. Okay, and if you see the features, so the features has yes, no, which has the maximum number of variants. So some of them are telling yes and some of them are telling no. So therefore we are telling that the last column, which is I think, which is let me check. Yes, so some are negative. Okay, mhm.
So all are negative.
Yeah, all are negative. So I'll just check. Does anyone have has anyone solved this? That why this is the maximum variance? Oh, sorry, it has least variance. Least variance. Sorry. Yeah, not the maximum variance. It has least variance. So obviously, as all are negative, we can say that this is our least variance data set, the least variant column. Okay. Now, Indranil was asking about, can we explain the violin plot part? So violin plot, in general, what we can see here, they are plotting the figure with a figure size, and then we are just we have imported Seaborn as SNS. So we just write SNS dot violin plot data equals to whatever data we are trying to gather. Okay, let us see whether 1 minute. Let me 1 minute. Let me just check whether sklearn has a uh, how to plot sklearn. Let's see whether we can create a separate violin plot. Violin plot. Mhm. Okay. Hey, hi Jaydev. I saw your lock and ilock part, ilock comment. I have to check it. Yeah, if you are what you are telling in the comment, if that is correct, yeah, please go ahead. Huh? I also have to
So
check.
if there is a Boolean mask, then alloc works.
Haha.
But Anand has just posted a counter example to that.
Oh my God. Okay.
So you have
Okay,
to
we'll
have a
see.
literal
We'll see.
Boolean map actually. Yeah.
Yeah, yeah. I'll see.
We can
So
take it on the thread.
yeah,
Thanks.
yeah, yeah. Sure, sure. I'll see. Yeah. So yeah. So exactly. So what we are talking to what's his name? Yeah, Indranil, is that how can we do a plot of the violin plot? Okay. So violin plot, I think. So what we can do here, I don't know whether yeah. So a violin plot is a similar as a box and whisker plot. So it shows the distribution of a quantitative data across several levels of one or more categorical variables such that they can be compared. So the violin plot features a KDE of the underlying distribution, unlike a box plot in which all of the plot components correspond to actual data points. Okay. So what is the difference between a box plot and the violin plot? Is that in a box plot, the components correspond to actual data points, but the violin plot actually features KDE of the underlying distribution. I think we had a let's see what is the wiki violin plot part task. Yeah, violin plot says. So Violin plot is a method of plotting numeric data similar to box plot with an addition of KDE on each side. Okay. So violin plots are similar, but what they show is the probability density. So basically, what you have here is see if it is a horizontal axis in journey, and it will show density plot, kernel density plot over the full data set. Okay, on both sides of the axis. So that is the box that is the called the violin plot. Okay. And so what is the advantage? Why are we doing that? So a violin plot is more, as you see that a violin plot is more informative than a plain box plot. And while a box plot shows the summary characteristics, the violin plot shows a full distribution of the data. As you can see from the density estimation plot, you can actually understand what is the much more distribution of the data. Okay. And if you want to see whether the distribution is multimodal or monomodal, actually, more than one peak is there, then the KDE shows the presence of different peaks. Okay. Yes, yes. So Shailesh, as I was showing, you can get the data set in our this thing, right? 1 minute. I was showing here. Yeah. This drive link is there. I'll also just plot in the sorry, not plot, but put in the chat window. So you can this link is given in the practice assignment. Huh? Yes, check. Anyway, as what else we have? What else we have? Yeah. So we were with violin plot. Now how can we do a violin plot, right? So there is a tips data set which we can use. I think I had the tips data set somewhere. Let me just find it. Let me yeah. I think it is the same data set. 1 minute. Huh? It should be this one. Okay. And once we upload the data sets, we have, if you see this column, so what does that data set have is basically our tips. So 1 minute, let me put it. So what does that data set have is that it consists of a bill of a bill which a restaurant has received, the total bill amount, the tips amount, the whether the how many people were there in each table which gave the tips, that amount, And let me show it to you. Let me show the data set to you. I think it is the same data set. 1 minute. Yeah, you can see this is the total bill amount and the tip amount which the person has given. What is the gender of the primary customer, whether it is a male or female, whether they are smoker or not, whether it is a Saturday, Sunday, Thursday, Friday, whatever, whether it is a dinner or lunch, and what was the customer size. Okay, so customer size means the total party size. What was the how many people were there for each customer. Okay, so for the first table there were 2 people, for the second table there were 3 people, and so on. Okay, there is a check window. You can use describe function and check standard deviation. Is it that one has to lot of values? No, obviously, as Bhupesh has told, you can use describe function and check the standard deviation as well. Okay. Now, yeah. So now, if we see import, so we are importing Seaborn. Okay, normal thing, importing Seaborn for plotting. Then we are setting some theme, setting some random thing for plotting. Plotting. Now we load the data set. Then do a violin plot. Please, whoever posted in chat, just wait. Let me finish this. Then do a violin plot. Let us see what it does. Okay, so this is total bill. How the total bill has been distributed. Okay, so this is the way we can define a violin plot. Let us see whether what is the tip amount. It's tip or tips, I think. Let us see these tips. No, tip. So how the tip has been varied, what is the distribution of the tip amount? That will be very small. So 0 to 10, and for 10 also the distribution is very less. So that generally the tip is between 2 to 4 only. Okay. Okay. Jaydev has posted something. Thank you, Jaydev. Anyway, so let us go back. Let us go back to the window. So Indranil, that is the way we can plot a violin plot. Does that solve your doubt?
Yes, sir. So we are here passing one single series as X and then plotting the distribution of that series.
Yeah, we are plotting the distribution of the values in that series. So how does X and Y, how does, say in this case, how does the total tip amount vary? Okay, so if you go through this data set, the tip you will see 1.01, 3.5, 4.2, not more than 10. Okay, there is no tip which is more than 10. If you see the column B here, okay, there is no tip which is more than $10 or so. Okay, so that is why what you can see, this tip amount is 10, maximum $10 around, and the most of the tips are around 2 to 4. Okay, dense around, they have coagulated or dense around the 2 to 4. That's why the density estimation plot, I think, is higher. Okay.
Okay, thank you, sir.
Yeah, so similarly you can do a total bill amount, whatever be the case, if we can carry on. Now let's see what else is there. Which of the following features has least number of outliers? Okay, which visualization marks outliers, improve or ignore or remove the missing values, if any? Least number of outliers. So what are they doing? They are using box plots. So because why now? Because box plots, as we have discussed, I think in Wikipedia we were seeing that we are seeing here, I think. Where we were seeing, yeah, I think it is in the Seaborn directory. So unlike a box plot in which all of the plot components correspond to actual data points, so KDE actually gives an estimate of the underlying distribution. So for understanding which of these data points has the maximum number of outliers, that we can get by from the box plot as well, from the box plot only. Okay, I am okay. Okay, I think Jaydev has answered. Thank you. Yeah. So similarly, we can do a box plot and see which of the data sets have the maximum number of data points. So I think V1 they are saying has least number of outliers. So least number of outliers, you can see V1 has least number of outliers.
Sir, in V4 also.
V4, sir.
Yeah, I think V4 also has a quite. I mean, there is no outliers actually, right? Okay, but V4 is not in the option, right? V4 is also not in the option. So I think if V4 was there, then we could say that V4 has the least number of outliers. But in V1, V2, V3, if you consider, then obviously V1 has the least number of outliers. Okay.
Sir, is there any way by which we can count the numbers of the outliers?
Yeah, I mean, basically we have to say that which of the count the number of the values which are less than the minimum value, right? What is the minimum or maximum? So in this case, count whichever values are greater than the 30 or whatever be the case here. Okay, isn't it?
Okay, I means basically we have to apply the basic code. Basic code will be required. There is no direct function. Basic code will, by applying basic code, we can if else condition like that.
Yeah. So if this is the case, then append it and count the number.
Okay. Sir. Thank you, sir.
Yeah. I think so. I think that is one way. I don't know if any other way is there. We can check. Okay.
Yes, sir.
Yeah. So which of the following is true about the target variable? It has higher yes entries than no entries. It has higher no entry than yes entry. It has the same number of entries of yes and no. Okay, fine. So basically we have to calculate the, we have to calculate the number of yes and number of no's in the target variable. And again, we have just plotted a histogram. Okay. So plt.figure, fine. Is y. Yeah, so y is the target variable. So I think y is the target variable, right? Let me check. 1 minute. Yes, so y is the unique. Yeah, y is the target variable, because we checked what are the unique values of y. So what we have here is a histogram of yes and no. So as we can see, the most of the target variable values are no only. So we can see that obviously it has higher no entries than yes entries, and hence option B will be correct. Okay, so there is a mistake here. I mean, A, B, C should be A, B, C. But anyway, so the middle option, it has higher no entries than yes entries, should be correct one. Okay. Now, what else we have? How many features have missing values? So we can just calculate the NaN values, and so we can replace the question marks with np.nan, okay, the NaN, and we can see that V1 has 5 NaN values and none of the others have NaN values. So therefore, we should have 5 NaN. Okay. How many features have missing values? Okay, so only one. Okay, sorry. So V1 and V2 both have NaN 5 NaN values. Therefore, 5 question marks. Therefore, we can say that 2 features V1 and V2 they have missing values in the data set. Okay. So therefore, option B is again correct. It will be correct. Now, what is the total number of missing values? It should be 10, right? Because we have seen V1 5, V2 5, so therefore it will be 10. Okay. Answer is C, right? Therefore, yeah, again we have just calculated the sum. Therefore, it is C. Let's see the chat window. Okay, I think Jaydev has helped. Okay, or Devopriyo Shaha has helped. Okay. Just a small thought, not related to this, but I hope all of you who are coming to campus for Paradox or seeing it online, attend. I think it will be nice to attend Ashish sir's lecture. He is giving a lecture on machine learning with JAX. So this is not related to this. I just remember. That's why I'm telling. So JAX is a JAX is seems to be, I mean, the new, what should we say, new kid around the block basically. Okay? And it is supposed to, I mean, it is told that it may replace TensorFlow, which is a very big statement. So I am also very interested, but still it is not very used. It is not exactly TensorFlow. It works completely differently. That's what I also saw. So you can see that it is not yet used in the companies, mostly in the research purpose, but for high performance. So NumPy and TensorFlow, both of it can be replaced most probably. So yeah, so although we have not started working with TensorFlow in this course, yes, PyTorch is also good. So let's learn that because maybe helpful, So anyway, let's get back. What is the yeah?
Sir, just sir.
Yeah, sure, please. Yeah.
Sir, in that for this workshop, we have received one Google form, and there were 5 options for the workshops. And the one workshop was that you are telling, that means.
Yes,
but I have chosen some another workshop. So I can, sir, is it possible to change it now?
I think if you are you coming?
Yes, sir.
I think it will not be a problem. I think so. I mean, the student volunteers, they are the main people here now. But I think nobody will disagree. I mean, you are learning something. Who will stop you from learning?
Okay,
you
sir.
Just come and sit in the hall.
Okay, sir. Thank you, sir.
Yeah. I think the form is basically to get an estimate of how many people, because according to that we have to allocate the hall also, right?
Yes, sir. Yes. Got it, sir.
So that's why there is no, I mean, no one should stop you technically. Okay?
Yeah. Thank you,
What
sir.
is the, sure. What is the average of the first feature after applying a simple imputer strategy equals to median? Okay, so they have used a column transformer, fine. And then a transformers equals to scale. So simple imputer they have replaced, and with simple the strategy equals to median. And then v1 they are replacing with np.nan, and then applying a fit transform. Okay, let's see. Answer E. 9.55 is coming, but there is some other warning coming. A value is trying to be set on a copy of a slice from a data frame. Okay, try using dot low equals to value. Did everyone get this this warning? Did anyone not get this warning?
I tried with a different approach, so I have not seen this warning.
Okay, I'll check if this warning can be removed. Okay, but anyway, if you go with this code, then you can see. I'll just put it in the chat window also. You can see that you should get the answer 9.55 and 9.55 to 1 or whatever. Okay.
Is it because of this transformers equal to? Because I was not using this transformers equal to, but I got no.
So can you write your can you paste your code in the chat window? We can try it, obviously.
Sir, I was doing it for the graded assignment, so I think it will match.
Okay, sure. I'll try. Okay?
Yeah.
So what did you do basically?
I just use this column transformer. Then under this first bracket, I use this.
Simply.
Yeah, exactly. So
Let us
just
see.
I just keep this transformers equal to. I didn't know.
Yeah, let us try. Let us try. So simple imputer. This is the one, right?
It should be under the third bracket, I guess. This
Column transformer.
yes.
Thank you. EC meta object is not subscribable. Where is it?
Okay, sir. I am posting my code in this chat.
Okay, no, don't post. I mean, anyway, it is for, as it is for graded assignment. No need to post. Okay, I'll check.
Okay.
No issue. Yeah. So anyway, let us. So what is the? Let us go to the
One
next.
question.
Yeah. Sorry.
For calculating median, does it consider NaN entries also, or it ignores NaN entries?
Sorry. Yeah. Sorry. What?
So when it is going to calculate the median, median will be on valid values, right? So will it consider NaN values also while sorting, or it will ignore NaN values?
So while we are using simple imputer, does it consider NaN values also? Is
Yes.
that the question?
Yes.
But I think that it should not be. I have to check, but I don't think it should consider, because even if it considers, it will be
that is logical.
ignored only, right? Because
it should be ignored.
we can't think. I mean, we can't approximate them to something, isn't it?
Right. So I was just thinking, like, if there is a large number of NaN values, suppose there are 100 values and 80 out of them are NaN, then does it make sense to have a mean or median for 20 values?
Yeah, I mean, that's a very noisy data set, sir.
In that case, we can use the other. There is a nearest neighbor imputer, right?
Yeah, that is.
Because if the data set is sparse in exactly the same locations everywhere, then anyway it's a small data set. But if one column is sparse, but corresponding values are present in other columns, then we might be able to get some estimate.
And sir, what if we ignore that column? Because
yes, obviously we can ignore the column, but
out of the 100, we have only 20 data set, and for other columns we have all the values. Then
yeah, I think if it is not
that is
required,
the simplest and best approach. Then.
Obviously, we can remove it. And so, what is the average of the first column after applying KNN imputer? Again, we have just said CT equals to column transformer. Then we impute using KNN imputer, and if we can calculate using the mean. We can calculate the mean and find it to be 9.56 and all. Okay, so that is also that should be the first option. Question 11 also asks what is the average of second feature, and so basically application of 2-3 imputing questions, nothing else. So what is the average of second feature after applying simple imputer mean strategy? Okay, so again CT equals to column transformer scale, strategy equals to mean, second column. So till now it was first column, I think. KNN imputer, first column. So for first column we were putting is 0. And now whenever we have come to second column, second feature V2, then we are putting 1. So 0th column, then first column, that is V2 feature. And then what are we doing? We are putting in the fit transform. Okay, this is NumPy. And then what we are getting? The average for mean strategy imputation. So we apply the fit transform. Again, we are applying fit transform here and calculating the mean. So the mean is coming to be 5.46, which should be our option. Okay, there are two. 5.46 is option C. Okay. So that is our practice assignment. Remaining are graded assignments. So we will not go into graded assignments now. So once you submit, I think graded assignment solution will be released. Okay, if in case graded assignment or both this full collab, the graded assignment and practice assignment solutions are not released, ping me in the chat, in the discourse. Okay. I'll publish them. There should not be, I mean, previous time also we have published, so it should not be a problem. Just let us know. In case it is not published, let us know. Okay. So with that, we end the program, the practice questions part. Now let us go into the other set of questions, which is big to solve with us. So this should be pretty easy. Our first task is we have to, these Kanika, these are from practice sets, as Bhupesh has told us. So import simple imputer from sklearn. Take a matrix. I'll keep the matrix in the chat window.
Sir.
Yeah, sure.
Just before moving into this part of the, sir, I was having one problem in the practice assignment. While calculating the simple imputer median value.
Okay.
Basically, in that V1 and V2 are the categorical data, and V4 is also categorical, means positive, negative kind of.
V1 is the, how V1 is categorical data?
Sir, it was showing in the info just because of the presence of the question mark.
Okay, but that we are changing to
that
NaN.
Right? Yes, sir. That I converted into NaN values V1, V2, and it became the numerical data. And sir, while applying the median in the data frame, it was showing that you cannot calculate median for the categorical data. That was showing for the basically for the V5 positive, negative. So I was thinking to convert this positive negative values into some kind of 0 ones, 0 or 1. Then sir, will it work, sir?
Calculating
I was trying to replace negative with a 0 and positive with a 1.
But V5, where do you impute? I mean, there is no, I mean, question mark or NaN value, right?
Yes, sir. But just because of it is the categorical data, so mean format was not applying in the data frame.
I mean, my question is, so you are, please tell me.
Sir, if I was passing the only V1, then it was saying that you cannot pass the linear one-dimensional data in the this formula.
Okay, so you are applying V1 and V2 both.
Yes, sir. We have to apply according to that error message. I had to apply 2D weight, two-dimensional value.
Okay.
So I was thinking to convert that V5 column into that kind of one kind of numerical data.
Okay, you can try, but my question was, I mean, V5 does not have any missing data, so I think, I mean, whatever you told is true. I agree that we can convert it to 0 and 1, and that will give a numerical value, numerical feature, right? That is true. But again, there is no feature to impute. There is no data point to impute, right?
Yes, sir. Yes, sir.
So again, that is not,
yeah. I think what see, even I tried the same way. What he's saying is that if you impute the whole data set, then it will give an error because V5 is categorical. But if you convert it into some kind of a numeric, then you can impute the whole data set.
Yes, sir. Yes, sir.
You don't have to do it column wise. I mean, column wise is a better method because it's asking, the question is asking for a specific column. But like it's shown in the videos, in the lecture videos, the whole data set was imputed. So even I used that method of imputing the whole data set, and it was giving an error because V5 was a categorical. I think that's what he's asking.
Okay, so you are suggesting to go column by column.
Yeah, that is better because otherwise we will have to convert that categorical into numeric, which is.
Yeah. So again, please try that. Let us see whether that works. Okay.
So, Mr. for converting the individual column, we have to use this formula. That CT is equal to this column transform.
Yeah, you can use that. I'll just post it in the chat window also. And also we have the previous this one also. I'm just 1 minute. This is the matrix which we are supposed to impute for the for the solve with instructor, and the next one is your column transformer. Okay, the KNN imputation part, which we are just discussing.
Yes, yes.
Yeah.
Thank you, sir.
Yeah, sure. Thank you, Jayadev. Also, yeah, that's a very nice answer. And okay, so any other thing on programming questions, practice questions?
Sir, I have a question, sir.
Okay, please tell me.
Yeah, so I was applying one-hot encoder on a feature matrix, but the thing is, I want to apply the encoding on a particular column only. But I mean, I don't know how to do that. So if you can tell me.
One-hot encoder on a particular matrix.
On a encoder or any transformer or any scaling, anything on a particular column.
That is what we were discussing right now. How to impute? Just see the chat window at the last message. We are applying a KNN imputer on one particular column, the first column of the data set. Okay.
Okay. So I will watch the YouTube recording, sir.
Yeah, just see the next just now the chat message that we put. I think so, right? I mean, Jayadev, is that?
Yes, we have received the code in the chat box.
Yeah. Just I'm pressing it again. Just yeah.
Yes. So this is fine. It works.
Yeah. Okay. Just see the Zoom chat window. I just paste.
Yes, sir. That I got it. Like you are using a pipeline to do that. That I saw in the video, and that I got it. But I want to use only encoding. I don't want to use any kind of pipeline. I want to use only encoding, and I want to apply that encoding on a particular column.
So what problem are you facing with that then?
Actually, in the pipeline, I have applied the pipeline, and like in the feature matrix, I have 5 columns. After applying the pipeline as it is said in the question, as it is as the instructions are given, I am getting 7 columns. So
and originally, how many were there?
Originally 5 were there.
Right. So that means that the column on which you applied one-hot encoding had 3 independent values, 3 unique values.
3 unique values. Sir, actually the encoding will be applied if you see the data set on the negative on the column which has the negative values column number 5. Yes, sir. 5th column. This one. E column. So I have separated 2 matrix. One is for the feature matrix, one is for the label matrix. And in the feature matrix, I am applying the one-hot encoder using the pipeline as you have given in the code. So after applying that, if you see, I mean, in one-hot encoder, if I have only 2 values, it will not update. I mean, it will not update the number of columns, right? It will not add any columns to the.
That is a special case, because see, if there are k unique values in a given feature, the output of the one-hot encoder will be of size k-1. Okay. Because if you want to communicate 2 distinct values, you only need one binary variable, 0 or 1, right? Similarly, if you want to communicate 4 of them, you need only 2. You don't need 4.
Yes.
So there is in one-hot encoder in scikit-learn, there is I think there is some parameter which drops 1 column by default.
And also, sir, like
so it will always be, if there are k values, then your output will be having k-1 columns. So yeah, that makes sense. If you have just 2 independent values in a particular column, it will only produce 1 column.
If you see the column number 5, I think you will get only negative. I mean, there are not any positive also. So that should not happen, no, sir.
So you'll only get zeros or ones in the entire thing.
Yes, so I will get only zeros and ones. So that will not add any. I mean, that does not require to add any column to the feature matrix.
Correct, which means you should drop the column E. It's not adding anything to your learning capability, or no variance is being added to the data set because of that column. So might as well drop the column. It's like, think of a simpler problem where you want to classify something based on height and weight, whether something, and if everybody has the same height, then drop the height because it's not contributing any classifiability or any learning capacity to your analysis.
Yes, sir, that I understand. And also, like after applying this scaling and simple imputer on the respective columns, I am getting, I'm getting a different kind of matrix. I don't know how it's happening.
Can you show us your screen maybe?
Yes, sir. Yes, sir.
Yeah. 1 minute. I'll stop sharing.
Sir, can you please allow me?
Oh, okay. 1 minute. Let me just check. Does anyone know how to allow? 1 minute. I think participants. Security. 1 minute. Can you check now?
Yes, sir. I can.
Yeah. Go ahead.
So is my screen visible, sir?
Yeah, now it is coming. Yeah, tell us.
Yes, sir. Sir, see here I have applied simple imputer on column 0 and 1, and one-hot encoder on column 4, and standard scalar on 0 to 3. And I ran it, and then I just I mean x, this x was the I converted this the feature matrix with nan values, that is np.nan, and after that I transformed fit and transform, and here is my fit and transform for the first 5 matrix, for first 5 rows. So here if you can see, the last 2 rows has this values, so which is not expected, because it should have 1 or 0. If we go by the one-hot encoder also. So that's why I was thinking of applying each of them without using the pipeline, each of them separately, so that I can view the output separately.
Can you show the pipeline once,
yes,
the sequence?
Sir. Yes, sir.
You see, you're adding scalar after one-hot encoder, which means that, see, these are chained, right? So the output of imputer will go to encoder, output of encoder will go to scalar.
Yes.
Even if the columns are independent, it's going to pass the same data frame or the same array through the entire pipeline. So what you can do is try to, like, x equal to simple imputer of x, then x equal to, again, one-hot encoder of x. So keep replacing the same variable and see if you end up with this. If that is the case, then you know that you can't chain them.
Okay, sir.
Or you'll have to find out some other way of making sure that you divide the columns into different kinds of variables. So have something like categorical variables, different variable, numerical variables, different variable, text variables, a different variable, and do it independently, then put them back together. That is also one option.
One another thing, sir, if I just separate them, like I have the feature matrix in this x. So if I want to separate this last column and then apply one-hot encoder on it, and then do the union again, as it is given in the question, as the flowchart is given. How can I do that, sir? How can I do the union?
We can use feature union, right?
Okay.
Yeah. Yeah. Sorry, please go ahead. Yeah, go ahead.
Sir, I have a question for this column transformer. Like, how is it executing these defined steps? Is it doing simultaneous executing these steps simultaneously, or passing this imputer to that encoder, the output of this imputer to this encoder, and then doing this? Because I was trying to use this column transformer for some process, But I was getting, but this column transformer was adding some extra columns. But after doing this in pipeline, I got the exact results, like those extra columns got vanished. So I just want to know that how is it executing these steps?
I think they will be executed line by line only. I mean, one after another. I think so. I have to check, but I think by one by one only.
Okay, sir. I will post it in the Discord. Like
yeah, just post it. I'll look into it.
Okay.
Ask some.
Okay. In parallel, only pipeline does it sequentially. The column is in parallel. But yeah,
okay.
there is a dependency of two different columns. Like in this example, you are doing something on 0, 1, and then another imputer on, sorry, another transformer column 1. Then there might be like implicit dependency. Do it in parallel for processing, faster processing.
No, if there is a 0, 1 in the first step, and then the next step there is also 0, 1, it will do both parallel.
No. In that case, I think it will apply intelligence.
Yeah.
There is no dependency on columns, then it will do it in parallel.
If there is no dependency on columns, then they will be parallel. And if there is dependency, it will go sequentially, right?
Yes, but that sequence, I think, is not defined, right? Which one will be executed first? Pipeline defines it clearly.
Yeah, that is true. No, suppose after the pipeline step, suppose here we have one hot encoder at, suppose in any step, I'm just telling, step A we have 0, 1 column, and in the step B also we have 0, 1 column. So in that case it will go again, already in pipeline it is defined, but then also it will go from fast execute 0, fast step, then come to step 2, right?
Right.
Yeah. Okay, that's what I was. Okay.
So in this, I have one doubt in this code, what you have just shown.
Abhishek was showing.
Abhishek, yeah. Even I didn't understand why is it behaving like this. I mean, why is he getting that? Because he specified different columns for, imputing. And then why should that one hot encoder column give those values? It's not clear.
Yeah, I have to check. I'll check. Where are you putting one hot encoder, Abhishek?
So he's put it on column number 5.
Yeah. I mean, in CT equals to column transformer, right?
Yeah, that negative. Yeah. Then why should, because it's only for that particular column he's put that one hot. But when he does the transform and he displays the value, even that is showing some odd values, which is.
Yeah, I mean, one hot encoder he is applying at 5 and he's giving some odd values.
Sir, here in the pipeline, you can see that I am only putting the simple imputer and I am choosing the column 0 and 1 for that. And here is the output matrix after transformation. So I think, I mean, some problem is happening here only. Like when the matrix is passed from after, matrix is passed after applying the simple imputer, then only the matrix is getting, matrix is getting disturbed in some way. So our output is not what we expect.
Okay. But so when you apply, actually, after applying fit transform,
only this simple imputer, I am getting this matrix. That is, and I think here I have only 2 columns. That is the first 2 columns.
Okay, can you just post it to me? Post the question. I mean, post the question once in Discord.
But this is expected, no? You are applying simple imputer on the first 2 columns and you are getting the right ones back, because I see that in the third row there are 2 labs and those are being replaced. What were you expecting?
So I was expecting like full matrix, but simple imputer.
Okay. So in column transformer, there is a parameter called remainder. So right before the closing bracket of the column transformer, add comma remainder. Remainder equal to in strings pass through. You see the default value is remainder drop, which means remainder of the columns drop them. That's what it does by default. Just type pass through over there.
Okay, okay.
So what does it do?
Run. It keeps the rest of the columns. It just passes through them. Doesn't drop them.
So in one of the videos, in one of the last 3 videos, professor while showing the code, he mentioned a step in the column transformer, like in double quotes he wrote pass, then comma, and then he wrote pass through. So is that the same step, sir?
I think so, but that might be a different version, because I'm looking at the latest docs and just type pass through and run the fit transform step again. Small p. I'm assuming this is the latest version because it's Colab. It usually maintains versions. Okay, try 105 and so on. Or you should get everything.
Yes, now it's working.
Okay, so
the default value for remainder is drop, which means that whatever is not applied in whichever columns are interacted with in any stage of the column transformer, only those will be kept. And so when you do this, anyway, all of them are being, you're touching all of the columns. That's why even without remainder equal to pass through, this will still give you everything.
So Jaidev, had this been in the beginning, like if instead of 0, 1, you would have 3, 4, and then the 0, 1 has to be 0, 1, 2 have to be passed through. So would the pass through come in the beginning and then the simple imputer?
It'll pass through everything. So basically, let me read out this. What it means: special case strings like drop and pass through are accepted as well to indicate to drop the columns or pass through them untransformed, respectively. So yeah, pass through means whatever you are not touching will be left out.
Okay, but the sequence should be in the right order, right?
I think so. Maybe you could try it out. I mean, I would be very surprised if they mess the sequence up.
Okay.
They should leave the sequence alone. I would assume that the sequence be maintained.
Okay. Yeah. Thank you.
So, sir, that means column transformer is running all the steps parallelly, right? Otherwise, if I am dropping these other rows and then I'm again calling those, then calling those columns, then it should raise some errors, right?
Yeah,
it has the capability to do parallel processing. There is another argument it takes called n_jobs. So by default, it doesn't do that. But again, before we talk about that, there is logical parallelism and there is actual hardware parallelism.
Okay.
So first of all, you have to figure out whether there is actually, the column should not produce a, directed acyclic graph or something like that. It shouldn't form a bottleneck. If that doesn't form, then you can process them parallelly. And then in order to implement that, you'll have to set some parameters in the column transformer itself.
Okay.
I think what Bhupesh is telling in the chat window, that is also very important here. So he checked from the column transformer documentation that all transformers are executed independently and in parallel only. So their results are concatenated at the end.
Exactly. That's why I was getting that error.
Yeah.
So some rows were getting added, columns were getting added. Okay.
Oh, interesting. So this suggests that the parallelism is by default, is it? If there is independence.
Then I used pipeline, and I'm not getting that error after using pipeline. So
correct. So because pipeline by definition cannot be like in a pipeline, things are not independent of each other. They are sequential by definition.
Yeah.
Okay. Okay, thanks. Let's solve some simple problems. Let's 1 minute. Yeah. We'll do some small things here. Let's see what is task 1. Yeah. So I'll post in the chat window, please. So everyone, I mean, not Jaidev or others who are, please do some things. Okay, some coding with us. Let's take some time to solve this. So import simple imputer at first, take a matrix and impute the missing values using both strategies, mean and median, and print the imputed matrix using fit transform. I know this is very easy compared to what we are just discussing. Let's do this because of the quiz and all. Okay. So yeah, can we give say 5 minutes for writing the code?
Fine.
Yeah, sure. Actually, while okay, fine, let's finish. While others are everyone is doing, let's just one small question. Do you think in courses live sessions in regional languages would be more helpful? And we were discussing yesterday, we are having a lot of discussions, and we want to discuss with you also whenever you are coming to campus. So do you think, does anyone think that the live sessions specifically in say regional languages also, say Hindi, English, Marathi, Bengali, those would be more helpful? Does anyone think so?
It can be helpful, sir, but then we have lots of regional languages also. So
yeah, I mean, yeah, obviously we can try some of them at least, not more.
Sir, I
but
think
again,
participation
yeah,
will be very low because today we have 24 participants. So if you split them, then it will again fall down. If you do
some of them also, then it will create some
divide, is it?
Yes. So it is better to stick to English because English is foreign to all of us. None of us are born learning English. I mean, it is mother tongue of no one here. So it is better to stick to English only. I think so.
Okay, I mean, nobody is facing issues with English, right? I mean, that's another thing because, yeah, I mean, we are trying to bring the pipeline and sorry, not pipeline, Python and everything in the fast foundation years. Whoever were in the foundation thing, foundation term. So we are taking those to the class, class 11, 12 students in government schools and all. So we do not know what is the English capability. That's why we were also thinking, would that be helpful? Would the regional languages be helpful or something? But yeah, I mean, whatever you told is correct. It would unnecessarily create a divide, and people will be less. Yeah.
Yes, sir. I mean,
and also the course content is already in English.
Course content is in English. Yeah, I mean, obviously, I mean, yeah, we can't
naturally English.
But I think the foundation level courses are already translated into 8 languages till now. So yeah, transcripts will be in 8 languages. So,
that's a good.
Okay. Yeah. Sorry.
Good to know that.
Yeah. I mean, that's true. But yeah, that's why we were thinking. So how can and another thing is, so I asked in the discourse also. So let's see. If some more responses we can get, that how can we improve the sessions and how can we get some more, how can we improve the course. Rajiv has gave us lots of input previous time, if you know Rajiv Banerjee. So we just discussed, we were discussing about what we can accommodate from those topics, what he suggested. Yes, let us know, and whenever you are coming, if you are coming next week, please discuss with us, and yeah, we will also try to know from you. Okay. Yeah, Indranil, please tell me.
Sir, is it possible to give us some kind of cheat sheet or this some kind of
notes?
Yes, for at least week 2, because for week 2 we are having so many functions, features. So
what do you want in the cheat sheet? Like what are the things you need? Let's note it down.
Some kind of summarized version, like just the API or the function and the actual function of that thing. So that will be
API of the functions functions mentioned in the
in the lectures.
Mentioned in the lectures.
Because we are not getting that collab, so it will be helpful.
Any
I'm also facing problems with the matplotlib. So multiple plots are there, but whenever I try to plot them out, I have some of the other error, and it takes a long time to debug it actually. So
I mean, don't you go to the sklearn manual and just copy the
I do, sir, but still, I mean, as I told you, it takes quite some time to go through it and understand what my error is actually. So whenever I try to plot that, so most of the even in sir's video, the matplotlib codes are normally hidden. So I am not able to go back and see there also.
I think that was my mistake. I mean, matplotlib. Okay, which code was hidden?
So the violin plot and the whisker plot, all those plots.
1 minute, I'll show you. Let's finish that. 1 minute.
It's the
data visualization, right?
Yeah, data visualization. Yes.
I think because I mean just by mistake it was just hidden. It is a box plot. This is box plot. That is violin matrix visualization. Scatter. I have to check where is violin. But I can assure you one thing: it is mostly taken from the sklearn manual only. Okay, they won't go far than. I mean, it won't go far than that. Any other place, because those are anyway. It is not in the. Let's see whether it is in the preprocessing collab.
So it's in the collab which corresponds to lecture 2.9, if I remember correctly.
Yeah, I have to see that. Can I just put a control F?
I beg your pardon, sir?
No, I'm just. Yeah, violin plot. Yeah, this one, right?
Yes, sir.
So a violin plot is this one. Which code you are telling is not there?
There were multiple plots actually, sir, in that lecture. So there was a violin, there was a box, and yes, the KDE plot all together coming, and then there was a histogram, which was a histogram of the combined plots. Yeah.
Box plot.
Yeah.
Acha, these things now. Wait.
Yes. Sir.
I'll just post in the chat window.
Yeah. Yes, sir. Thank you, sir.
Yeah. Where is chat window?
So when you say palette set 2, is there any? I mean, is that a color or something like that here?
Palette is color. Palette
is
as far as I remember, that was color. This is box plot. Then we have violin, right? This is violin. There is KD. Anything else?
No, nothing else. Thanks, sir. Thank you.
Yeah. Sure.
Even this one, sir. The histogram also, I was making some error somewhere.
Histogram. This one, histogram.
Yeah.
Just save it. Save the chat window.
Yes, sir.
And
yes.
KD
I got it, sir. KDI I could do it.
Anything else?
Nothing else, sir. Thanks a lot. Thank you, sir.
Sure. Yeah, just let me know. I mean, I saw in video. I mean, I faced previous time also that some codes were hidden. So I mean that was just by mistake. Mistake means nobody saw that that thing was hidden. So that's why there was a problem.
Fine, sir. Yeah.
So just let us know, or if you face any problem like this, just post in the chat window, Discourse. We will paste the code.
Yeah.
Yes. Yeah, what else we were seeing? So matplotlib, so this thing is gone, right? I mean, whatever is required is done, right?
Yes,
anything
sir,
else
it's done. As of now, yes, it's done.
Yeah, okay, let us know. Anything else we should include in the notes? Any suggestions from anyone?
Sir, I don't know. I mean, it's a
yeah, tell me.
Big thing to ask. Like a few of these APIs, like how are they working? Just a gist, like how are they doing this encoding and transformation? That would be really helpful for our concept.
One suggestion that I have is like the previous lectures do explain the APIs, but they just tell what this API and what these parameters are. It will be good if we can have a sample data set in the starting of the week 2, and we start running the APIs on those sample data rather than just showing the presentation.
I mean, in video.
Yes.
That too. I mean, then we have to ask sir to again record the lecture. That I think. I mean, this term may not be possible. In the next term, that will come, but this term that may not be possible.
It's just a feedback.
Yeah, I mean, sure. That anyway we are doing. I mean, whatever you will read in this term, okay. So 12 weeks of content in the next term, that is getting suppressed into 4 weeks, and 8 weeks we are taking 8 data sets, and we will apply the full from data loading, data pre-processing, and everything on the data sets.
Perfect.
Okay, so that is one plan. Another thing I think which is coming to you, or is that, so how many of you have Kaggle experience? So how many of you have? Can you maybe raise your hand or something, that how many of you have participated in Kaggle or know about Kaggle competitions? Jaydev, yes, obviously Jaydev has should have experience. Other people, Bhupesh, I don't know. Bhupesh, do you have?
No, sorry. Actually, I tried to participate, but it said like you don't have the.
Yeah, so that may be mandatory. Mandatory means that may come, that some part of the coursework is to either we will host or we will some competition. Okay, either hosted by us or hosted by someone else. We will participate. That may come
really
this time. Okay.
That will really help.
Yeah. So we agree. Some Kaggle experiences. As everyone talks about Kaggle, so yeah, it is necessary to have some experience. Huh? So thank you. Yeah, we will see. So that thing may come. Everyone, if possible, please look into the Kaggle website, and there is the first thing is a Titanic. Titanic data set, and predicting how may which passenger which passenger may have lived, and which passenger may have died from the Titanic data sheet of the list of passengers. Okay, so please look into them. And Kaggle has a lot of things mostly. So it has a business intelligence, it has a practicing ground, courses, so many things are there. So Vivek has asked, how are others doing it? Yeah. Okay, what was the issue? Okay, I cannot copy from chat. It shows select options on. Okay. Oh, is there a problem of copying from chat?
Yes, sir. Yeah.
Why you can't copy from chat? Okay, in case. Yeah, just see. I mean, if there is a problem, yeah.
I think Command C is not working. Right click.
Yeah, Kanika has suggested to use right click. Just let me know.
Not,
okay. Yeah. In case
this
does not work.
Working with right click also. I think, sir, you have to give the. I just googled. It seems the admin has to give the permission.
What permission I have to give? 1 minute. Let me see.
It's working on Android devices. I can copy it from my tab, but I think it's not possible in computer.
I have
I'm
allow
working on
participants
laptop.
to share screen, unmute, start video, a chat window. Let me check the chat. When I don't have any. Okay, in case you can't copy, just let me know in Discourse. Huh? I'll paste the codes again. Something like that we have to do.
We can take a screenshot.
Huh? Sorry?
We could also take a screenshot of.
I can't hear you.
We could also take a screenshot of that.
Yeah. I mean, obviously, whatever works for you, man. Yeah. So just see. Let me know. So anyway, so one is an API of the functions mentioned in the lectures and the gist of working procedure, like encoders and transformers. Yeah. Okay. Fine. I'll use this. So anyway, I think. So is week 1 any notes published? In week 1, is any notes published yet?
No, sir. Not yet, sir.
Okay, we are making, so I am not sure whether it is for this term or next term. Okay, I'll put this. Okay, let me try to make it. I'm not sure whether we are able to make week 2. I'll try to make it. Yeah, many works are there. Okay. Yeah. So where were we? Yeah, this one where was the solve with us? Yeah. So anyway, we are here. We have imported simple imputer and we took a matrix, and this is pretty simple. I think. I mean, we have imported the numpy as np, and from sklearn.impute we import simple imputer, and then we obviously, as you all know, so we impute with mean. We have a simple imputer with strategy equals to mean. Then we do a fit transform on the matrix, and we take the matrices as given to us. Okay. So what did they ask? They asked to impute the missing values in the matrix using simple imputer, and we print the imputed matrix using fit transform. Fine. Now, do you see any change in the results between the imputing and imputing with mean and imputing with median? So obviously there will be some change, I think. So first one is with mean. Okay, so where are our missing values? Okay, so second row, first two values, 9.78, then this is 9.81, 1.22 into the power 3, 1.22 into 10 to the power 3, okay, fine. 8.135, 8.135. Okay, so some changes are there. Anyway, let's go to task 2. We import function transformer from the sklearn library, and we apply log base 10 to the elements of the following array: 0, 1, 2, 3, 10, 100, and print it. So again, from sklearn.preprocessing, we import the function transformer. Transformer equals to, then we take a log, we apply log base 10, right? So np.log10 is the log 10 log base 10 transformer. Okay, but what is this thing, Kanika? I think okay, we'll look into this later. Yeah. So and after that we print the transformer after fit transformation. So we do a fit transform of the we do a log base 10 log operation on the matrix which is given to us 0, 1, 2, 3, 10, 100, and then we go and fit transform the value. Transformation cases state pipeline. I don't know what is that. Anyway, now read the CSV file from machine learning database IDs dataset. Okay. Define the column headers as sepal length, sepal width. Yes, obviously. So basically take the IDs dataset. Sepal length, sepal width, petal length, petal width, label, and generate a KDE plot, a box plot, and a violin plot. Can we do this? Can we take some time and do this? J.S. Ranjit has asked, can you please explain how to proceed with graded question? Ranjit, I think I answered that question that you asked about the graded question in Discourse. Ranjit?
Okay, sir, I'll just see what.
Yeah, just see once. I think I mean, we should not discuss once before the deadline, but I just posted the steps which are required used to solve the program, solve the question. Just see whether the steps make sense to you, Yeah.
Okay, sir.
Oh, yeah, sure. So, yeah, people who are asking for the KD plot and box plot codes, can we apply and see whether the codes are working now? Read the CSV file and make a KD, a box plot, and a violin plot. Maybe, yeah, take again 5 minutes, should be more than enough. Then generate a correlation plot between the features. Generate a new feature matrix, do a polynomial transformation. So if it is a two-dimensional and of the form a comma b, then the degree to polynomial features are 1 comma e comma b comma a square comma ab and b square. Okay, so these are the variable powers which are possible. Then you print the shapes of the feature matrix before and after polynomial transformation. So take IRIS dataset, do a KDE, a box plot, a violin plot, and if possible correlation plot between each pair of features, plus like IRIS that we have done. Then we generate a new feature matrix and do a polynomial transformation of degree equals to 2. Okay. So let's do this.
So during our OPs, we are not allowed to open the sklearn documentation, right?
So guys, when is the week 2 deadline, graded assignment deadline? Can you just let me know?
Tomorrow, sir.
Tomorrow, na? Okay. So if the solutions are not posted on Monday, Tuesday around, by Monday at least, just wait till end of the day. Yeah, everyone is busy. Just let me know in the discourse. Just tag me. Then let me know 2 things: solve with instructor PDF or file, Python file, and practice and graded solution. Python file or PDF file. Let me know. Because sometime it may get lost. Okay, just let me know. I will push for releasing it. Huh? Okay. Acha, let us see the code then. We have 1230. So again, it's the same thing. We have the column names, and we have the iris data set, and then we plot a KDE. Of course, it is a single-sided KDE, right? So in only one side we have plotted. I have not seen the. Yeah, thank you, Vivek. Yeah, I think my mic was mute. So we have the different block KDE plots and the box plot as well. So from box plot, actually, you can see that. So you can analyze different values, right? I mean, so what is the median value of of your sepal length, sepal width, and which one has the maximum, which has the maximum value, maximum median value maybe. So that is a sepal length, huh? Right? So some questions like that also is there. Is there means that we can check. Then we have similarly violin plot, which is vertical, set one. So someone was asking us about this now, that what does the set one and what's the palette mean. So if you see, let us see whether what happens if we put set two. Set two, I think, is this green, red, this color, the same color. And what happens in set three? And so on. So basically we can do these things. I won't waste your time, and so on. So this kind of things can be possible. So anyway, what are the columns? And okay, so we are listing the columns, and after that we are listing the polynomial features that we can provide, right? So polynomial feature transformations that we are providing. So these are the columns that we have. Obviously, we have sepal length, sepal width, petal length, and what is the level of the flower, right? So we have setosa, virginica, and all other things, on the other two things, right? Versicolor and setosa, virginica, versicolor. What is the other one? Can anyone tell me what is the other one? Setosa, virginica, versicolor. I'll check. Anyway, nobody remembers? Yeah, okay. From sklearn.preprocessing, we import polynomial features, and then we see what are the number of features before transformation. So then we can calculate the number of features from e dot shape. So the shape is 5, and once we apply a second degree transformation, so there can be a and b was a b c d and 1, a b c d and 1, that was previously, right? So now it will be 1. Yeah, so polynomial transformation actually is giving us a more number of features. Okay, polynomial transformation is giving us a more number of features. So if you see the column, the number of features has increased from 150,5 to 150,15. Okay, so this is how the shape changed. So the shapes.
We will use this. I think that is.
Yeah, that is one question. So that is one question. Let me check. That I think we were answering that. Let me check. Huh? Generates a new feature matrix consisting of all possible polynomial combinations of the features with degree less than equal to the specified degree. The number of features in the output array scales polynomially. Okay. But why is it required?
So there are some good examples on TensorFlow Playground which show why we need this.
Can you share with us? Can you share with us?
Let me. May I share my screen?
Yeah, please. Please go ahead.
Okay, is my screen visible?
Yeah. Visible.
Let's ignore the fact that we are using neural networks here. Let's bring this down to only one neuron. So this is essentially logistic regression. Now, there are two input features and there's just one neuron. This is a trivial case of a neural network, which is exactly a logistic regression right now. Now, look at the kind of data we have. This is clearly not separable with a straight line. Right? So, what this means is that a single logistic regression won't be able to solve this. Because a logistic regression is, say, capable of drawing only one straight line. We can't do this. If it was something like this, like let's see. So now this is trained very quickly, right? In 100 epochs or so. But here, if you keep running, it will keep on fluctuating, jumping around until it finds some minimum loss, but it will never actually do very well. Right? So what we do is, these are our input features, x1 and x2, which are simple features. Let's add some polynomial features. x1 square is a polynomial feature, x2 square is a polynomial feature, x1, x2 is also a polynomial feature. And now we run this, and there you see it. So whenever in the original space of the data, x1, x2, or x3, whatever, in the original space it is not linearly classifiable, you can use polynomial feature extraction to turn it into something that becomes classifiable. Is it clear?
X1 and X2, and what is the difference when we scared? Like,
so that becomes a polynomial feature, right? It's a second degree feature. X2 square is a second degree feature.
Shape remains
X1,
same.
X2 is also a second degree.
Yeah, that I understand. But in the output, the shape remains same, right?
No, this is the training data. No? The output actually is not the training data itself. Look at the colors, the boundary between the two classes. Yeah.
Okay, I'll explore it further.
Yeah, I mean, it's a clear example, right? I mean, when we are using, can you just show x1, x2 only?
Just x1, x2.
Yeah. So now see, it is not particularly we can't classify it properly. But when we have x1 square, now can you switch on x1 square, x2 square?
So
yeah, I mean all those.
Start x1, x2. Let's only do this, or let's do one by one, right? I start with only x1 squared again. Now, why is this appearing like this? Because x1 is on the x-axis, x2 is on the y-axis. We are doing x1 squared means that becomes like a parabola, right? And that's exactly the parabola we are seeing here. If I switch x1 squared off and put x2 squared on, you'll see the corresponding parabola along the y-axis.
It means it is for a better fit.
Exactly. So, but when I put those two parabolas together, I get an overlapping region in between. And that is an external feature for me, which is derived from the original feature, sure, but it is still an external feature which I can use. And if we just look at x1, x2 itself, that produces this sort of, it's a hyperbola. This is also not great, right?
If the simple linear regression fails, then we try the polynomials, right? Because upfront we won't know whether it will fail or not.
Good point. So actually, in most cases, upfront, it is very difficult to determine whether the data is linearly separable or fittable or whatever.
Exactly.
So you have to try out these things. There's only one algorithm which actually tells you whether that is the perceptron. If you remember, anybody who's done MLT, or you're probably going to encounter the perceptron. So, sorry about that. Just a second.
Yeah. Proceed. Please proceed.
Yeah. So perceptron is pretty much the only algorithm which within finite time can tell you whether the data is linearly separable or not. But of course, the key there is that it's finite time. You don't know how much time you're going to need to determine whether it is separable or not, whether it is linear or not. So again, practically, that means that there are no guarantees. You can't do anything much. So you have to keep on trying these different heuristics and see what works best.
Okay.
So one doubt. So basically, can we summarize and say it's just to better fit a model? I mean, it's just like that Taylor series that was there. You increase the number of and the x1, x2 is basically interaction between two variables. So if I want to see the effect of, say, media on advertising and say another TV and media, so I see the interaction.
In the polynomial features class in sklearn, there are parameters like interaction only or exclude interaction, include interaction, and those all sorts of combinations you can do. If you say we don't want interactions, it will only generate x1, x1 squared, x1 cube, x1 to the power 4.
So it's an extension of the linear regression.
No, it's not regression at all as such. It will just produce the features.
Yeah, but I can, if I have coefficient in front of these features, say like you have x1, x2,
exactly,
and say,
so then you have
so
to
then I can say
you have to take the features from the polynomial features, and uske aage, then you have to add the estimator object, which is your classifier or regressor.
Right. Okay. Thanks.
Yeah, I think this was a very nice example. Thank you, Jay.
All right.
Yeah.
Do I stop sharing?
Yeah. You have stopped.
Oh, it's already stopped, is it? Okay.
Yeah. Okay, where were we? Yeah, let's see. Let's solve the next question then. So basically, yeah, 1 minute. Let me share. Sorry. Yeah, so then we have did a pair plot of a grid plot of IRIS data set. Okay, so yeah, in the code I'll just post here. You just check whenever you are free later. This is very easy. I mean, not very much important thing. One noted thing you can see. I mean, this the diagonal curves are sepal length versus sepal length, petal length versus petal length, then sepal width versus the third one is then sepal width versus sepal width is the second row, and then petal length versus petal length, and the fourth one will be petal width versus petal width. So all of those are just one single line, right? Because they are just correlation of them with themselves, self correlation, right? And others are separate zones you can classify, right? So you can classify different. So sepal length versus this axis is sepal width. So sepal length versus sepal width, if we do, we see the different clusters. Here, like for some cases, the clustering is quite distinct. So sepal width versus, if you see sepal this graph, petal length versus sepal width, then we see that there are different clusters, which helps us properly to identify the data sets. Anyway, let us go to the next question. We import one hot encoder class from sklearn.preprocessing. Print shapes of the matrix. Which matrix? Before and after one hot encoding. Okay, the iris matrix, iris labels matrix. Okay. E dot label. What is E dot? 1 minute. Achha, so A is the iris label. A is the iris dataset only. Okay. So A is the iris dataset only. So please read the matrix and import one hot encoder and apply it on the one hot encoder. Apply the one hot encoder on the the iris matrix, and print shape of the matrix before and after one hot encoding, and print some particular rows, 45th row to 55th row of the matrix after one hot encoding. Okay. So if you see, we have what we do is we import we import ordinal encoder and one hot encoder. So one thing is both of them are from sklearn.preprocessing. So we can just say from sklearn.preprocessing import ordinal encoder comma one hot encoder in a single line. That would also work. So then what we do is we apply one hot encoder with the category. What is the category? Category equals to auto. So what is one hot encoder again? Let us see what is auto and everything. So category equals to auto. One hot encoder encodes the categorical features as a one hot array. Input to this transformer should be an array like should be an array like data set basically. Okay. And so after that, what we do is we print the shape of the matrix before encoding. So if you print the iris matrix label, ID matrix shape. Then you see one hot encoder, and after that we apply fit transform. And so we first of all we define the one hot encoder, and first is so then the first print statement is on what is the shape of the matrix before encoding. Then what we do is we apply one hot encoder and fit transform on the iris labels matrix, and we print the shape of the matrix after encoding. Okay, so you see in the 45th row to 55th row there is a change. So at first they were of the, I think, Setosa category. I have to check, but they were of the Setosa category, and then they changed to Virginica. Okay, Virginica or vesicular something is there from the second row. So that is in the this portion. Okay, shape of the matrix before were 150,0, and then it became 150,3. So that is about applying one hot encoder. Similarly, what we have is again, so basically this is where we are practicing, and please apply like please practice like this. So importing different data sets. So it's like import California housing data set and select percentile, mutual, info regression. These things you import. Then you select features according to the top 10 percentile. Okay, and then you print the shapes of the feature matrix. So you know what do you need? You need select percentile. You need trend test split. Obviously, always we need trend test split, and we need California housing datasets. Now, California housing dataset is already available in sklearn.datasets. So you obviously NumPy as a NumPy always is required. So these small things you import every time. Import NumPy as NP. Import from sklearn.model selection. Import trend test split. Mutual information, mutual info regression. These things are generally required, right? So better. I think I would suggest better to import them. Okay, and I mean write it so many times that gets etched in your memory or something like that. Fetch California housing first of all. Then what we do is we divide the, so this line was not required from sklearn.feature selection import select percentile. This we have already done in the first case. So what we do is we define the X California and Y California, and we fetch California housing. Then we select a subset. So the first top, I think we are selecting the up to 1,000 elements of the data set. Okay, the up to 1,000 element of the data set, so that we can calculate it properly. We can calculate it fast. So we have X California, the first part, and the feature matrix, the X California, and Y California also up to 1,000 elements. Then what we do, we apply select percentile. And what is the percentile? The percentile is top 10 percentile, right? So percentile equals to 10. Then what we do, we print the shape of the feature matrix before fit transform, before applying the before fit transform. Then it is 1,000,8, and once we apply the top 10 once we apply the fit transform of top 10 feature matrix, not top 10 feature matrix, top 10 percentile, then only we get only one column, right? So from 1,000,8 it comes down to 1,000,1. So the top 10 percentile has one column only in the California housing data set. Okay, so things like that is required. So in suppose in case of quiz, it can come like, suppose we show you this code and we say we have selected not top percentile, you have selected top 10 top 8 top 8 features. So what will be the shape of the, and this is the output of what will be the output of this code? We give this code and we say x the number of the features is equals to 8. So then what will be the output of the code? Okay, output of the code x new dot shape. So then it will be 1,000,8. Previously, suppose it was whatever 1,000,10. If it was, then it will be 1,000,8. Okay, things like that. Then let us see another one, and maybe we will end with this one. The rest of the things, whatever is remaining, please, we will upload in the window in our portal. Okay, just follow the codes and I mean, go through the codes. Try to practice them. I will try to write the notes as you told. I'll see what I can do. Okay, and yeah, so let's see. And let me know if the graded assignment solution, the practice assignment solution, and the solution solve with instructor files, they are not uploaded by around Tuesday or sometime. Tuesday morning should be the maximum time. Okay, if they do not get uploaded, just ping me in Discourse. Okay. Tag me. Yeah.
Will this collab be shared in the portal?
It will be. It will be.
Okay.
Actually, previous time it was already shared. So I'll just ask them to share it in the portal again. If they do not do, if you see it is not there, just tag me in Discourse and post it. Okay.
Okay, sir. Yeah.
Okay. Yeah. Okay. So a column transformer named Fantastic 4 with a block pass through inside it we generate. Then we have what other blocks are there. One is a simple imputer using mean strategy and a standard scalar operator named STD scalar. So you generate a categorical pipeline applying label binarizer on the fifth feature. Combine these two pipelines using feature union, display the full pipeline diagram. I think this is where that import OS import request things were required. Let me see that will work. So the things are simple. So we have to just generate a structure, column transformer named Fantastic 4 with a block pass through, a simple imputer using mean, and a standard scalar operation. Okay, standard scalar operator named STD scalar. A categorical pipeline using label binarizer on the fifth feature. Okay, let us see. So firstly, we import everything from sklearn.preprocessing. We import standard scalar. Then we have label binarizer, and from sklearn.pipeline we have we import pipeline feature union, column transformer, and imputer. Fine. Okay. So we have a pass-through block. Selector is the object, and the function is select first 4. Just does pass through. Okay. So it selects the first four columns, right? So slice 0,4. Acha. Then what it does with that first 4 columns is 0, 1, but it should be 0, 1, 2, 3. Anyway, 0, 1, 2, 3 up to 4. Okay, fine. 0, 1, 2, 3, 4. It has done slice 0,4. Then we apply an imputer with okay, nothing. Then we have we apply an imputer and standard scalar. Jayadev, are you there?
Yes, I'm here.
Jayadev, do you know what does this thing represent? Slice 0,4?
No, that seems like, I mean, given the way it's highlighted, seems like it's some sort of primitive, but what is it doing in a column transformer stage? I don't know.
Yeah, I also not sure.
I think it's taking the first 4 alphabets.
No, it is not taking first 4, right? It is taking first 5. 0, 1, 2, 3, 4.
First 5 alphabets.
First 5 alphabets.
So basically, the first transformer is called Fantastic 4 and passed through the first 4 columns.
First 5 columns.
0, 1, 2, 3, 4 is 4 included in when you try write something like that?
Okay, I'll look into it. I'll look into it. So everyone, yeah, I'll look into why what is the purpose of this slice 0,4.
However, if that is the intent, that if initial first k columns have to be dropped, then there will be a better way of writing this.
Yeah, I think so. Yeah. No, because it is not there in the slide in the column transformer page. Okay, I'll look into it. Yeah, no issue. So anyway, we have a categorical pipeline where we apply a label binarizer on the fifth feature. So on the fifth feature means so this is how we represent. So inside a square bracket, we put 4. So on the fifth feature, we apply label binarizer 0, 1, 2, 3, 4. Okay, fine. And then we have a full pipeline. So how do we, combine the two pipelines? We apply feature union with a numerical pipeline, which is num underscore pipeline and categorical pipeline. These two we apply feature in union and we combine them. Then what we have is from import sklearn, from sklearn we import set config. So set config equals to diagram. So what we display in the diagram, we see that this is a pass-through block, and the numerical pipeline has a simple imputer also. So the simple imputer has median strategy and standard scalar. The other one is a categorical pipeline, which has a label binarizer on the fifth feature, right? Fifth feature means 0, 1, 2, 3, 4. So that means on the fifth feature we have, and after that we go to this feature union, and feature union is oh my, so feature union is taking both of the numerical and categorical pipeline and combining them together. Okay, so that is how we can represent HTML representation of the pipeline is possible. Okay, so I guess we'll stop here. We have some more questions on PCA. Anyway, we will upload the question and answers as well. So just look into them and let us know if some issue is there. I'll try to answer them. And okay, we'll stop the session here.
So can you show the task 9 also? We'll probably
yeah, let us sure.
Right. Thank you.
I'll post in the chat window also.
Right.
I don't know why you can't copy it from the chat window. It's something which I have to inform them again. Okay.
Thank you.
Yeah, sure. So this is so basically we are doing a sequential feature selector, 3 features to select and 3 neighbors, and load the IDs dataset. Then we perform a wrapper-based method, wrapper-based feature selection using SFS. Okay. So I think we yeah. So what are the n number of features to select? So we have wrapper-based and feature-based selection methods, right? So then you apply SFS dot transform, and you calculate what is the shape of the transform matrix. So it should not be much difficult. Check. Let us know if so there is no only iris dataset has been loaded, but it has not done much of a calculation on it. Yeah. So we just are calculating the transform direct shape. Okay. Okay. So yeah. So let's stop here, and yeah, let us know what is the, if there is any issue, and if someone else has a problem, anything you need, and ping me if this thing is not there, the PDFs or the Python notebooks are not there. Sometimes it happens. One person to another person goes. There's some delay. We'll let you know. The notes I'll try to write, but I'm not sure when it will be finished. I'll just inform you. Okay. If it is published, if it is ready, I'll publish it. Yeah, I have to go and get it checked by others, get it checked and corrected by others also. Okay. Yeah, let's finish here, and yeah. Bye.
Thank you, sir.
Yeah, sure. Thank you. Thank you, everyone. Hope to see you next week. Okay.
Thanks.